The last lesson for this unit is on applications of probability. So we're just going to look at one common application, which is using a standard deck of cards. And then we're going to look at some other ways we use probability in order to make decisions. So the first part of this explains what you will find in a deck of cards. And if you're not familiar with what they call a European standard deck of cards, there are 52 cards. Of those cards, half of them are red and half of them are black. And we have 4 different suits. So there are the spades, the hearts, the clubs, and the diamonds. The suits have 13 cards in each. Those cards are the ace, and then we have the numbered cards 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then there's the jack, the queen, and the king. Those are called the face cards, and that constitutes the entire suit of cards. Of those cards that are black, the spades and the clubs are the black cards, and the hearts and the diamonds are the red colored cards. So that is what the deck of cards looks like. If you are using if you're being asked questions on how to determine the probability, theoretical probability with a deck of cards, you basically need to understand that. And if you don't know it, you can always refer back to this paragraph that explains it. I'll provide it for tests, or if you're doing something an assessment online, you can just have it open with you. So the question we have for example 1 is to determine the probability of each of these sort of events happening, and we have the probability of getting a 6 of spades. So the 6 of spades, there is only one 6 of spades, just like there's only one of each type of card and suit combination. So there is one possible outcome, one successful event out of 52 possible events, the 52 cards. The probability of getting a diamond, question B, there are 13 cards in each suit, so it's 13 divided by 52. The probability of getting a black card, I'll just move to the next page, there would be 26 black cards because it would be all of the clubs and all of the spades, so that's 13 plus 13 out of 52. And I didn't write it in lowest terms here, but you should. So that would be 1 out of 52. Just check quickly. It says to express your answer in lowest terms. So I'm going to fix this file to make them all in lowest terms. And then we have the probability of a jack, queen, or king. And that is 12 out of 52. Because those are the face cards. There are 3 face cards in each suit. So there are 12 altogether. The probability of getting a 2, there would be 4 2s because there's 1 2 in each of the 4 suits. So 4 out of 52. The next part here says that we can use probability to make decisions. And it mentions how a manufacturer might use probability. You might use probability to determine how to pick stocks or funds. You'll see that in some future questions. But the last point here says that when you're making decisions based on probability, it's important to remember that the probability of an outcome for an event is independent of the previous outcomes of that event. So if you flipped a coin 5 times and you got heads 5 times, that doesn't mean the next time you flip you're more likely to get heads or you're more likely to get tails the next time. You have a 50% chance of getting heads and a 50% chance of getting tails on each coin flip. So the question, for example 2, it says if a coin is flipped 100 times and the coin turns up heads 37 times and tails 63 times, If the coin is flipped 100 more times, would you expect the experimental probability of turning up heads to increase or decrease? And so this is kind of a complicated question because the experimental probability of heads and tails after 100 flips is 0.37 and 0.63. So it's more likely that the experimental probability of flipping heads will increase, right? Because it's a 50-50 chance. If we go 100 times, you'd expect that to increase. But because each coin flip is an independent event, we can't say for sure whether the probability of turning up heads will increase or will decrease. We could say that it's more likely, but we can't. You can't likely expect it to happen. It's just it's a more likely event that will happen. Let's look at the support questions. So it says here, what's the probability of drawing each card from a standard deck of playing cards? And we have the probability of drawing a queen. I won't do these ones for you, but I'll just I'll mention the answers in their lowest terms. There would be a 1 in 13 chance of getting a queen. There would be a 1 in 13 chance of getting a 5. There would be a 1 in 2 chance of getting a red card. There would be now an odd card is a bit different. I was ready to say it was a 1 in 2 chance, but with an odd card, you wouldn't count the ace, the jack, the queen, or the king as odd cards or even cards. So here, what you'll have to do is you'll have to count how many odd numbered cards there are between 2 and 10. And determine the probability of that. So I'll leave that with you to figure out. And the last one I'll leave with you as well. It's what's the probability of drawing a 15? So I'll leave that one with you as well. Number 2 here says, a dealer draws a jack from a standard deck of cards. He shuffles the card back into the deck and then draws another jack. He shuffles the deck once more and draws another jack. If he shuffles the deck once more, would you expect him to draw a jack the 4th time? And I'll leave that one with you. If you are curious, you can email me or ask me. That one's a special trick question, so I want you to work on that one on your own. Question 3, it says an auto parts manufacturer must reject a part if more than 5% of the parts in a sample are defective. So if 240 parts are tested and 8 are defective, will the batch be rejected? So here, what we'll need to do, let me just pull up my my camera, and I'll move the questions up there. What we'll need to do here is we'll need to determine what is the probability that we've got when we have 8 defective out of 240 parts. So if I just divided 8 by 240 on my calculator, I'll end up with 8 divided by 240 works out to, that's going to be 1 over 30, I think. 1 over 30, or what works out to, if I'm going to write that as a decimal, 3.3% approximately. That is less than 5%, so the batch will not be rejected in this case. Now the next one says, if a casino offers a new game, it's called Test Your Luck. To play, you draw a card from a deck. If it's a heart, then they'll match your bet. If it's black, they keep your bet. So would you bet money on this game? So let's do a small little probability tree just to figure out how this works. So we have a card is drawn. It's either a heart and it's black, or it's the other type of red suit. It's a diamond, which in this case they don't say what happens. So that means that they're basically going to it's going to be kind of like a tie. So you have a 1 in 4 chance of getting a heart, a 1 in 4 chance of getting a diamond, and a 1 in 2 chance of getting a black card. This is a win, this is a loss, and this is a tie. So you have a 25% chance at winning, 50% chance at losing, and a 25% chance at having a tie. So all together in this game, you're more likely to lose than to win. So you could say that this is a game that you would not play. The only kind of benefit here is that it's roughly 50-50. It favors, if you tie, you don't lose anything. You get your money back. But because you are more likely to lose than win, the casino is favored in terms of gaining money from this game. Now let's look at our what our lesson is going to, or assignment's going to look like. So the first question is kind of straightforward. You're just answering what the probability is of certain cards being drawn. The second question is making a decision, looking at manufacturing process. So I'll leave that for you to try to figure out. The third one is kind of describes a situation that you'll have to determine whether it's whether you would be more or less likely in order to win. So basically, you and a friend are deciding on who's going to pay for dinner, and the person who pays, rather, it's up to you. If you bet, or you're going to make a decision on whether it's going to rain or not, and then you check the weather forecast, and you're trying to decide if you are more or less likely to pay for dinner. So it's all about looking at the theoretical probability and trying to figure out if your decision is likely to happen or not. So of course, do that work, take a picture of it, and then submit it online or email it to me, and that is that's what you will be doing for this lesson.